So we're going to look at dividing lines in a ratio in this lesson. So this is in your notes, page 138. And what this is we're going to look at two different methods for how we can find the coordinates of a point which divides a particular line into a given ratio. So the example here, you've got the coordinates of 2 points. It's points in 3 dimensions, and you're being told that the point T divides the line joining these 2 points P and R in the ratio of 2 to 3, and you are being asked to work out the coordinates of the point T. So you've got these instructions, if you like, or steps set out. So what this is saying to you, step 1, make a sketch of the line showing the ratio in which the point divides the line segment. So if we then mark down the point P at one end of the line and our point R is at the other end of the line, and then what we're saying is we've got this point T, which is part of the way along the line, 2 bits along the line, and then 3 bits here. So we've got 2. It's splitting up the line in the ratio of 2 to 3. So that's step 1, and that's my advice, is just to draw a line, put your points either end, get your point. It's not in the middle, notice, because it's in 2 parts to 3 parts. And then, right, we're using the sketch. We're going to equate the ratio of the 2 line segments with a given ratio. So what that means is you're basically going to say, a bit like what we were doing with our collinearity. So when we compare the vector that goes from P to T compared to the vector that will go from T to R, we can see that there will be 2 parts there compared to 3 parts here. And that's what the second bit is about, getting you to that step. Once you've got to that step, it's then saying cross multiply, then change the directed line segments to position vectors. So cross multiplying here will mean that we're going to have 3 times PT will be equal to 2 times T to R. And then using your position vectors, that will mean that you can write that as 3, and then open up your brackets, T minus P equals 2 times, and remember position vector for T to R will be R minus T. Then it's saying step 4, rearrange to give the position vector of the unknown point. So that would be the position vector of T, so we will try to isolate that. So basically if you multiply this out, a bit of algebra, you get 3T minus 3P equals 2R minus 2T. So I'm going to collect all my T terms on one side. So that would mean I would have 5T if I added the 2T, and I add the 3P onto the other side, I will have 2R plus 3P. And so to work out your T, you're going to be doing, I'm going to have to divide by 5 or do a fifth of 2R plus 3P. So that's us rearrange to give the position vector of the unknown point, and then from that we're going to be able to work out the position vector if we put our components in. So we can work out that the components, I'm going to use square brackets, so I'm going to have 2 times R, so my R is 8 minus 1, 19, and I'm going to have 3 times minus 2, 4 minus 1, and that's going to give me T equals 1/5 of, I'm going to work each of those out, so you're going to have 16 minus 2, 38, plus you will have minus 6, 12, and minus 3. That needs added together, and when you add that together you'll get a single vector. So we get T equals 1/5 of, we will have 10, 10, 35, and that's going to give us that t will be therefore equal to, and this is position vector of t, right, will be 1/5 of all of that, so we'll get 2, 2, 7. Now the question is asking you to find the coordinates, right, find the coordinates of the point t. If we've worked out the position vector of the point t, then we can write down the final answer, right, will be that the coordinates of t will be 2, 2, 7. Now it's important you write them as coordinates because that's what it's asked. If it asks you for position vectors, that's what you write, but if it's saying coordinates, that's what you need to be writing. Now that is one method for how you can find a point using directed line segments in this way, or equating the two using the ratios. There is something called the section formula that's an alternative to this. So you've got a wee bit of a note of this at the top of page 135. You don't need to worry too much about where it comes from, or even memorising that formula there. I would tell you not to, but what I would say to you is the type of diagram actually that we began with at step 1 is very useful for this. But I will show you, we'll do it because your question 2 on that page is exactly the same as what we've just done, but we begin like we had. But what I'm going to say is that we're going to just write down in the same way, but I'm going to have my coordinates here this time. So I'm going to have -2, 4, -1, that's my point P. My point R at the other end is 8 - 1, 19. And I'm going to be trying to find this point T, and I'm going to list it as having coordinates X, Y, and Z. And we know that it's dividing up that line in the ratio of 2 to 3. So I'm going to then do this little kind of arrow diagram. And what that is to help you see, this is different method. This is actually using the section formula. What the section formula says, to work out the x coordinate for the t point, we will do this number here, the 2 times the opposite one, so we would be doing 2 times our 8, plus we will have 3 times the x coordinate of the first point, so 3 times -2. And then the whole thing is all divided by 5, and that's because the line gets really split up into 5 bits, so you're doing 1/5 of that. If you work that out, you'll see you've got 16 on the top there. You're going to have 16 minus 6, so you'll have 10 over 5, which is of course 2. If you do the same thing with the y coordinate, so taking your y coordinate and you do 2 times the y coordinates, so we'll be doing 2 times the -1 plus then 3 times the 4, and that will also be all over 5. And again, if you do that, you'll end up with -2 plus 12, which is going to be 10 over 5, so you get 2 again. And then for the z coordinate, you do exactly the same. So you do 2 times 19 plus 3 times -1. Right, 3 times -1, and that all over 5, so that's going to give us 38 minus 3, which is 35 over 5, which is of course 7. And therefore your point T has got coordinates 2, 2, 7, and we've just been able to work them out using the section formula. You can also write down that the position vector is 2, 2, 7. Right, so the coordinates of the point T would be that, and that was what we got before. So I don't know whether you prefer the vector method to it, or using this, what's called the section formula. But basically when you use the section formula, and like I said, you don't need to memorise it in this sort of form here, but what you're actually doing each time is this term times the opposite one, and this number here times the opposite vector for each of these, and then you need to add on the bottom is a sum of what these ratio values are. So that's I wouldn't worry too much about as I say, learning or memorising the section formula, but actually being able to use it in practice, I personally think is relatively easy compared to the first method. Right, so just another couple of examples. In this question here, you've got a cuboid and you've got the corner points, or they're giving you the points A, C and G, and they're saying to you that the point H divides the line BF in the ratio 4:1. So we know the point, we don't know the coordinates of the point B, so we would need to work them out. So we know that C is the point 8, 0, so that means we're coming along 8. We know that the point G is 8, 12, 8, and then 12 in the way, and then you're also given the point 8, so we've got a height of 5. So that would let us write down that the point B has got coordinates, therefore 8, 0, 5, and your point F, which is here as well. So we're trying to work out both of these points, and this is just using your three-dimensional diagram to get your coordinates. So you could get your coordinates for F by doing 8, 12 and then 5. So 8, 12 and then 5. So now that we've got the coordinates for the points, we can do the little line diagram. So there's your point B at this end, and its coordinates, right, 8, 0, 5, and then your point F, which has got coordinates 8, 12 and 5, and then we are trying to work out the coordinates of H, which splits up that diagram in the order of, or in the ratio of 4:1. So do your little cross, and you're going to be looking for X, Y and Z. So I'm going to use the section formula to do that. So I'm going to work out the X coordinate of the point H would be worked out by doing 4 times 8 plus 1 times 8. So 4 times this 8 and then 1 times this 8. So you're going with the X's, and then we're totaling to get the 5. So that's going to give us the X coordinate 40 divided by 5. So that is going to be 8. And then we're going to have Y. So the Y coordinate 4 times 12 plus 1 times 0 all over 5. So we're going to have 48 over 5. So that's not going to work out to a nice number. And then our Z coordinate would be the 4 times the 5 plus 1 times the 5 for your Z each time, and then dividing by 5. So that does give you 25 divided by 5, which is 5. So from that you can then write down that the point H will be 8, 48 over 5 and 5. And then one last example, same sort of thing. You're being told that the points are collinear and you're asked to find the ratio in which Q divides PR. So you've seen how to do this sort of thing before, so we would work out P to Q, so we would have Q minus P, so that's just normal result. So we've got 8 minus 3, 1, minus 6, 1, minus 3, and that's going to give us 2, minus 4, positive 4, and then we would also do the same thing to work out your Q to R. So we're doing R minus Q, which would be 9 minus 5, 3, minus 8 minus 3, 1. and that would be given as 1 minus 2, 2. So now that we're looking and comparing these two things, two ratios, when you know they're collinear, then you know they're a multiple of each other. So it's this one here that you can see, if you like, as a factor of the other one. So 2 minus, take out the 2. So you can see that this one, the P to Q one, is twice the Q to R one. If we were writing down or trying to draw a little picture about that, if you think about it, so you've got this P to Q is definitely the longer one. So P to Q made up of 2 bits of the vector, and then Q to R, so you're going to have that 2 to 1. So when it asks you about what's the ratio that we're divided, or that Q divides PR, the ratio would be 2 to 1. Or you could also write it like this. You could say P to Q, Q to R would be equal to 2 parts to 1 part is what you'd be looking for there. Okay, so that you've seen that sort of thing before. Now it's time to practice. Exercise 13 and N, and you're looking at questions 13 to 24. The first 12 questions in that exercise are good for overall general practice at showing your knowledge of the basic vector work.